All right, let's work through our sample test together. Starting with our first question, find the exact value using sum and difference formulas for the sine of 75. All right, so I want to find values that I know from the unit circle that I can add together to be 75 or subtract to be 75. There are lots of different combinations that you could use. Anytime I can use values from the first quadrant, I prefer to do that because everything in the first quadrant is positive and I don't have to worry about positive and negative signs. So for me, I would do this one by doing the sine of 30 plus 45 since both of those are in the first quadrant. All right, so I'm going to use my sign addition formula. So on your formula sheet, if you look for the sine of A plus B, you get sine A cosine B plus cosine A sine B, all right? And we're putting 30 in the place of A and 45 in for B. So now I'm just going to look at my unit circle and see that the sine of 30 is 1/2. The cosine of 45 is square root of 2 over 2. The cosine of 30 is square root of 3 over 2. And the sine of 45 is square root of 2 over 2. All right, so 1 times the square root of 2 would give us square root of 2. 2 times 2 would be 4, so square root of 2 over 4. And then square root of 3 times square root of 2 would be square root of 6, and 2 times 2 would be 4. And you can leave it separate, or you can combine it over that common denominator. Either one of those is perfectly fine. All right, for the next one, cosine pi over 12, the first thing I would do is rewrite pi over 12 with degrees instead of radians. So remember that we can take 180 and divide it by 12, and that gives us 15. So I'm looking for the cosine of 15. And again, if I can use values from the first quadrant, I would prefer that. So I could do the cosine of 45 minus 30, or 60 minus 45, or 135 minus 120. I mean, there are lots of different options, but using the smallest values I could from the first quadrant, I chose 45 and 30. So your cosine subtraction formula is cosine cosine plus sine sine. Watch that formula carefully. All right, so cosine 45 off of the unit circle is square root of 2 over 2. Cosine 30 off the unit circle is square root of 3 over 2. Sine 45 is square root of 2 over 2, and sine 30 is 1/2. So then square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. And then square root of 2 times 1 is square root of 2. 2 times 2 is 4. And again, you can leave that separate or you can combine it. Now, to me, the hardest problem on the whole test is tangent addition and subtraction. So for tangent 105, again, I'm going to try and find values that will add to be 105 or subtract to be 105. Lots of different things that I can use, but if I'm trying to stick with the first quadrant, then I would rewrite 105 as 60 plus 45. All right, so my tan addition formula is tan A plus tan B over 1 minus tan A times tan B. So we're putting 60 in for A, 45 in for B, 60 in for A, 45 in for B. All right, so we go to our unit circle, and the tangent of 60 is square root of 3. Tangent of 45 is 1. And then 1 minus tangent of 60 is square root of 3, and tangent of 45 is 1. So that gives me the square root of 3 plus 1 over 1 minus the square root of 3. At this point, I'm done with the trigonometry. It's the algebra that is such a pain from here. But if you've gotten to that point, you've already gotten half of the credit for this problem. All right, so to simplify that, I need to get rid of the radical in my denominator. So I'm going to multiply by the conjugate. So the conjugate is when you have the exact same numbers, but the opposite sign in between. So I would have the 1 in the square root of 3, but I'd have the opposite sign in between. And what you do to the bottom, you have to do the same thing to the top. All right, so I'm going to FOIL my numerator. So square root of 3 times 1 would give me square root of 3, and then square root of 3 times square root of 3 would be square root of 9, or 3. 1 times 1 would be 1, and 1 times the square root of 3 would be square root of 3. So that's where we get our numerator, square root of 3 plus 1 plus the square root of 3. If we simplify that a little bit, 1 square root of 3 plus 1 square root of 3 is 2 square roots of 3, and 3 plus 1 is 4. So 4 plus 2 square roots of 3. All right, now let's work on our denominator. So again, we're going to FOIL. So 1 times 1 gives us 1. We're forming this denominator down here. All right, and then 1 times a positive square root of 3 would be a positive square root of 3. 1 times a negative square root of 3 would be a negative square root of 3. And negative square root of 3 times positive square root of 3, negative times positive would be negative. Square root of 3 times square root of 3 would be 3. All right, so the positive square root of 3 and negative square root of 3 drop each other out. That leaves me with 1 minus 3, or negative 2 in my denominator. Now remember, you cannot cancel these 2's or this 2 with this 4. You can't cancel things that are being added and subtracted. So what I need to do is see if there's anything I can factor out of my numerator. And sure enough, I could take out a 2. Now because that 2 is being multiplied, I can cancel that 2 top and bottom. That still leaves me with a negative 1 in the denominator. So 2 divided by negative 1 is negative 2. And the square root of 3 divided by negative 1 is negative square root of 3. All right, now they ask us to find the sine of 75, but this time using a different method. They want us to use our half angle formula. They want us to use u divided by 2. So I need to think about what divided by 2 will give me 75. Well, 150 divided by 2 will give me 75. So I'm going to replace u with 150. All right, so looking at my formula sheet, my formula is plus or minus the square root of 1 minus cosine u, so again we're putting 150 there, divided by 2. Look on your unit circle, the cosine of 150 is negative square root of 3 over 2. 1 minus a negative would be 1 plus the square root of 3 over 2. And to add these two fractions, I need a common denominator. So I'm going to rewrite my 1 as 2 over 2. So now that's going to give me 2 plus the square root of 3 all over 2. So 2 plus the square root of 3 all over 2. That was being divided by 2 over 1. So remember, when you're working with fractions, we stay, change, flip. We're going to change our division to multiplication, and we're going to change 2 over 1 to be 1 over 2. All right, so we changed our division to multiplication, and we changed our 2 over 1 to 1 over 2. All right, so now in my numerator, I still have 2 plus the square root of 3. And in my denominator, 2 times 2 is 4, and each of those still under a radical. Not allowed to leave a radical in the denominator, so down here, square root of 4 would just be 2. It is no problem at all for me to have a radical inside a radical in the numerator. Now, the last thing I have to figure out is this positive or negative? And that depends on the quadrant. So if you go back up, we're trying to find the sine of 75, right? 75 is in the first quadrant. So in the first quadrant, everything's positive, so that's why we put the positive out front here instead of the negative. All right, they asked me to find the cosine of 15 using a half angle formula. So again, I want to think of what divided by 2 gives me 15. Well, 30 divided by 2 gives me 15. So I'm going to put 30 in the place of u. And you'll notice it's the exact same formula, just one sign change right there. So 30 in the place of u. So I'll look on the unit circle. Square root of 30 is square root of 3 over 2. And so I have 1 plus the square root of 3 over 2 over 2. Now, if you go back for just a second, we had 1 plus the square root of 3 over 2 over 2, right? So we're going to get the exact same answer here, right? So again, just some algebraic simplification. I'm going to rewrite my 1 as 2 over 2. And so I'm going to have 2 plus the square root of 3 all over 2. 2 plus the square root of 3 over 2. And dividing by 2 is the same thing as multiplying by 1/2. So again, here's our numerator and denominator. Square root of 4 is just 2, so I don't have a radical in the denominator. And because cosine of 15 is in the first quadrant, everything's positive there, so that would be a positive. All right, then tangent 105, using half angle formulas. What divided by 2 is 105? Well, 210 divided by 2 is 105, right? So I'm going to use my formula, 1 minus cosine, and I'm putting the 210 in for u over sine 210, all right? So if you look on your unit circle, cosine 210 is negative square root of 3 over 2, and sine 210 is negative 1/2. Now, a common mistake that I see on these is you replace the 210 with negative square root of 3 over 2, or you replace the 210 with negative 1/2, and you leave the sine and cosine there. It's the cosine of 210 that's negative square root of 3 over 2, right? So that whole thing gets replaced, and this whole thing gets replaced. Okay, so now we're back to joyful algebra again. 1 minus a negative is going to be 1 plus, so I'm going to need a common denominator. So for 1, I'm going to rewrite that as 2 over 2, so that I could combine my 2 plus the square root of 3 all over 2. Dividing by a negative 1/2 is the same thing as multiplying by a negative 2. So that gives us our 2 plus the square root of 3 over 2 times negative 2 over 1. So the 2's would cancel, leaving me 2 plus the square root of 3 times a negative 1. So 2 times negative 1 is negative 2, and square root of 3 times negative 1 is negative square root of 3. All right, the next one says if sine is equal to 5/13 and u is in quadrant 2, find the exact value, and they're going to ask us to do several things here. Sine 2u, cosine 2u, tangent 2u, half angles, all using the same information. So the first thing I want to do is I want to draw a second quadrant triangle, all right? So it's like here's my y-axis, here's my x-axis, so I'm drawing in the second quadrant. And I know that sine is opposite over hypotenuse, so sine would be opposite over hypotenuse. Then I need to use Pythagorean theorem to find the other side, so we use Pythagorean theorem over here to figure out that b could be a positive or negative 12, or you might recognize the 5, 12, 13 triangle. Now I have to figure out whether it's positive or negative, and the fact that I'm in the second quadrant, remember that your y value would be positive and your x value would be negative in the second quadrant. We also can check our signs right here in just a second, all right? So to do these next couple of problems, we're going to need to know the sine, cosine, and tangent from that triangle. So let's start with sine. Again, that was given, opposite over hypotenuse, 5/13. Cosine would be adjacent over hypotenuse, negative 12/13. And tangent would be opposite over adjacent, negative 5/12. So with that information, to find sine 2u, I'm just going to grab the formula off of my formula sheet, 2 times sine u times cosine u. And so we'll put 5/13 in for sine, and we'll put negative 12/13 in for cosine, because again, that's what we got up here. And again, as we said, the sine and the cosine go away. They're replaced by the value. All right, so 2 times 5 is going to be 10, times a negative 12 would be negative 120. And then 13 times 13 is 169. Now, something to be careful of here, this 2 is over 1. That 2 does not get multiplied by that 13. That 2 is over 1, so it's 1 times 13, giving us the 169. All right, so using that same information, now let's find cosine 2u. You have 3 different formulas for that. I like to use the one that only requires the given information where I can. So that's why I chose 1 minus 2 sine squared since sine was given. So I'm going to put 5/13 in the place of sine. And now I'm just doing order of operations. So 5/13 squared would be 25 over 169. And 2 over 1 times 25 over 169 would give us 50 over 169. Again, the 2 doesn't get multiplied by the denominator, right? So to combine these, I need a common denominator of 169. So I'll rewrite my 1 as 169 over 169. So 169 minus 50 will give me 119 over my common denominator of 169. All right, then they ask us to do the tangent using that same information. So let's go grab our tangent formula. So tangent is 2 tangent u over 1 minus tangent squared. And we've already found tangent is negative 5/12. So we're going to replace tangent u, that whole thing, with negative 5/12. And we're going to replace tangent u, that whole thing, with negative 5/12. Notice there's no trig function left in here, like no tangent left in there. And now we're back to order of operations, right? So 2 times negative 5/12 is negative 10/12. And then negative 5/12 squared would be a positive 25 over 144. So that's 1 minus 25 over 144. So I'm going to rewrite my 1 as 144 over 144 so that I can combine with a common denominator. So 144 minus 25 is 119 over 144. And that negative 10/12 in the numerator, we just reduced down to negative 5/6. All right, so when you're dividing fractions, remember you're going to do stay, change, flip. So the negative 5/6 stays the same, the division changes to multiplication, and this 119 over 144 flipped. All right, so I'm going to do any simplifying that I can. So the 6 goes into 144 24 times. So now I have negative 5 times 24, which is negative 120. And down in the bottom, 1 times 119 would be 119. All right, using that same information, now let's find the sine of u divided by 2. So go grab your sine u divided by 2 formula. It's this guy right here, plus or minus 1 minus cosine u over 2. So cosine u was negative 12/13, so replace cosine u with negative 12/13. And so minus a negative would be plus. That'd be 1 plus 12/13. All right, so 1 plus 12/13. I'm going to rewrite my 1 as 13 over 13 so that I can have a common denominator. So I'll have 13 plus 12 is 25 over 13. And then that was being divided by 2. So division by 2 is the same thing as multiplying by 1/2. So we will have 25 over 26. So square root of 25 is 5, but that still leaves me with square root of 26 in the denominator. Not allowed to have a radical in the denominator, so let's multiply top and bottom by the square root of 26 to rationalize. And that gives us 5 square roots of 26 over 26. Now, this is not positive or negative. It's one or the other. And so to figure that out, they told me that u was in quadrant number 2. All right, if u is in quadrant number 2, where is u divided by 2? Well, if you take quadrant number 2 and you divide it by 2, you get 1. If you'd rather think of it in terms of the degree values, all right? In the second quadrant, it's 90 to 180. If you divide each of those values by 2, that would be 45 to 90. So u over 2 would be between 45 and 90. And again, that's the first quadrant. So the sign in the first quadrant would be positive. Remember that the cosine u over 2 formula, the only difference is that this is a plus right here instead of a minus. So literally this sign would change to a plus, and then everything else is going to be the same. All right, so if we want to find cosine of u over 2, like we said, that sign just changed to a plus. So we're going to have 1 minus 12/13. So 13/13 minus 12/13 would be 1/13. All right, then we were dividing by 2 over 1. Dividing by 2 is the same thing as multiplying by 1/2. So 1 times 1 is 1, and 13 times 2 is 26. So we get the square root of 1 over 26. Now, square root of 1 is just 1, but that still leaves me with square root of 26 in my denominator, so I'll have to rationalize. So let's multiply top and bottom by the square root of 26. And I'll end up with the square root of 26 over 26. Now I have to figure out if it's positive or negative. And just a moment ago, we talked about how we could know that u over 2 was in the first quadrant. So if it's in the first quadrant, then this sign would be positive. All right, then tangent u divided by 2. There are two different formulas for this. You can use either one. It'll give you the same thing. So we've got 1 minus the cosine over the sine. So the cosine was negative 12/13, so 1 minus negative 12/13. And the sine was 5/13. So again, notice we replace sine u, the whole thing, with 5/13, not just the u. All those trig functions go away. And now we just have algebra to do. So minus a negative would be plus. I need a common denominator here. So I'm going to say 13/13 plus 12/13 is 25/13. 25/13 divided by 5/13, we're going to stay, change, flip, right? So stay, change, division, and multiplication, flip that second fraction. The 5s will simplify, and the 13s will simplify, and that'll leave me just 5 over 1 for my answer. All right, then for number 13, they have us going backwards. For number 13, it says, use sum or difference formulas to simplify cosine 100, cosine 80 minus sine 100, sine 80. All right, so if you look on your formula sheet, you're looking for something that is cosine, cosine minus sine, sine. So like cosine u, cosine v minus sine u, sine v. So if you look on your formula sheet, cosine, cosine minus sine, sine is cosine addition. All right, so if you'll notice, 100 is lining up with u and 80 is lining up with v. 100 with u, 80 with v. So let's come over here and put 100 in for u and 80 with v. So that gives me the cosine of 180. Now, notice your directions say give your answer in simplest form. Like don't leave it cosine 330 if you can write it as square root of 3 over 2. So same story here. Don't leave it cosine 180 if you can simplify that down to negative 1. All right, then we want to do our sum to product and product to sum. So this one says to do sum to product, and we have sine plus sine. So look on your sum to product formulas for sine plus sine, and you should be using sine u plus sine v is equal to 2 sine u plus v over 2 cosine u minus v over 2. So again, you can see that u lines up with 5x and v lines up with 9x. So over here, u is 5x, v is 9x, u is 5x, v is 9x. All right. So 5x plus 9x is 14x divided by 2 would be 7x. And then 5x minus 9x is negative 4x divided by 2. That would be negative 2x. There is no way to combine these any further. That is my final answer. All right, then going the opposite way, if we want to go from product to sum. All right, look at your product to sum formulas. You're looking for sine times cosine. All right, so if you look and find sine times cosine, it's sine u cosine v is equal to 1/2 sine u plus v plus sine u minus v. All right, now notice that this one has a 2 out in front. So whatever we get for sine times cosine, when we get that answer, we need to multiply it by 2. All right, so you can see we're going to put u in the place of 8x and v in the place of 6x. So u in the place of 8x, v in the place of 6x, and then 8x for u, 6x for v. All right, so 8x plus 6x gives me 14x. 8x minus 6x gives me 2x. All right, in my formula, there was a 1/2 out in front of that formula, right? So there's that 1/2. And remember that our problem had a 2 out in front. So we said that whatever we got for our answer, we were going to multiply it by 2, right? So 2 times 1/2 would cancel out and just leave me with this guy. So like we said, 14x and 2x. No way to combine those. That is my final answer.